Hello, welcome to Math with Beth, and we're going to look at optimization problems today and finding absolute max and absolute mins. And we will be using the first derivative in order to do this. So let's take a look. So, optimization. The extreme value theorem says a continuous function f defined over a closed interval a to b must have an absolute maximum value and an absolute minimum value over that interval. So let's think about what this means. So first, if a function was not closed, it could go on forever. And so this type of function does not have an absolute max because it keeps going up and up forever. Same thing with absolute min. It does, however, have a relative max here and a relative min here. So what this is saying is if you have a continuous function like this, but it's on a closed interval, so it does stop in each side, there will have to at some point be a point that's the very highest or a point that is the very lowest of the graph. That's it. So here's how you can find it. By finding your derivative, finding your critical values, and then listing those values along with the endpoints to see which one ends up giving you the highest or the lowest value. So I'll do an example so you can see. So if I wanted to find the absolute max and min of this function, I would first find the derivative. Then I'd find any critical points by setting it equal to 0 and factoring if I can. 3 can't equal 0, but if I set x squared minus 1 equal to 0, I would end up eventually getting 1 and -1 as my answers. So -1 and 1 are possibly min or maxes, but then remember we're on this closed interval that starts at -2 and ends at 3/2. So if one of these critical points wasn't even in this section between -2 and 3/2, I wouldn't even worry about it. But now I'm going to take each one of those and I'm going to plug each of those numbers into the original function to see what do I get, because the largest of these answers is going to end up being the max and the lowest is going to be the min. And if there's a tie, then you can just have more than one max or min. So carefully going back to the original equation, f of x, and plugging in -2, I would get 0. Plugging -1 into the original function, I would get 4. Plugging in +1 to the original function, I'd get 0. And plugging in 3/2 back there, I would get 7/8. So if you're having trouble plugging these in and getting the right answers, feel free to leave me a comment and I can show you this step by step. So the largest number I got was 4. So this is definitely my absolute max. But the lowest value is 0. So since I got that twice, both of these are going to be my absolute mins. So there's a couple ways you could say that. You could say I have an absolute max of 4 at -1, and I have an absolute min of 0 at -2 and 1. So this point ended up being nothing special. Let's try it again just with a little fancier equation. So again, finding the derivative of this, just be careful. The 2 would still be there. E to the 3x stays e to the 3x, but then you also have to multiply by the derivative of 3x. So really you get 6 e to the 3x. So now if I want to find the critical values, I can set that equal to 0, divide by 6, and I still get 0. Take the ln of both sides, and you're going to have a problem because you cannot take the ln of 0. So when you get to here, you know that this means there are no critical values. So all that means is we have no numbers to add to the fact that I definitely already knew that I needed to check what was happening at -2 and 1/2. So plugging these in, we're going to get decimals. So plugging in -2, I get this. Plugging in 1/2, I get this. So here is my absolute min, and here is my absolute max. So that's it. Just remember to always test your critical values, if you get any, and the endpoints to see which is the largest and which is the smallest. Let me know in the comments if you have any questions about that. Thank you.